I've been looking forward to this. Dean Radin is a researcher and an author in the field of parapsychology. He is senior scientist at the Institute of Noetic Sciences in Petaluma, California, and a four-time former president of the Parapsychological Association. He has held appointments at Princeton University, Edinburgh University, University of Nevada, Las Vegas, SRI International, Interval Research Corporation, and the Boundary Institute. At these facilities, Dean was engaged in basic research on exceptional human capacities, principally psi phenomena. I think many of us would group psi phenomenon such as ESP, clairvoyance, precognition, and telekinesis in the realm of science fiction as opposed to science. Despite there being little support for this research in academia, I was surprised to learn how much there actually was. The Princeton Engineering Anomalies Research Lab spent 3 decades working on this research. SRI International has funded a large body of research in this area. Governments around the world have funded these studies for potential military applications and other uses. My curiosity about this led me to Dean Radin. I met Dean at a conference a few months ago. I was impressed with Dean, and I wanted to give him a chance to speak in front of this audience in particular. While this type of research brings an incredible amount of skepticism, I respect both Dean's scientific background and his intellectual honesty enough to listen with a discerning but ultimately open mind.
Thank you very much, Jessica. Science and the Psi taboo. I'm going to read a story here. One Thursday morning, about 4 a.m., I jumped out of bed, feeling as if I was dying. I felt as if blood or something was pouring down from my head, choking me, and I was trying desperately to get my breath. I grew very weak. I thought I must really be dying. My husband put me down on the bed where I rested, but felt so all gone. Oops. Let's restart that later. Then I thought my son had called saying, "Oh, Mama, help me," in such anguish. That was February 10th, and on the 12th we received a telegram saying our son was killed by gunshot in the head at 1 o'clock on February 10th. There is a 9-hour difference in time. I feel he called me as it was happening, as it happened, and I heard his groan and felt his dying. This was published a few days ago in the Journal of Cognitive Neuroscience. The original story comes out of a collection of such cases by Louisa Rhine, who was J.B. Rhine's wife, in 1981. Well, what do we do with such stories? They're, of course, called psychic phenomena. They're abbreviated psi. There's a number of people who will consider it superstitious nonsense. I suspect typically in technical audiences that percentage is higher than in a general population, but it depends on whether you're asking people publicly or privately, which is part of the nature of the taboo in this topic. So there's some people who say it's superstitious nonsense. There are lots of other people who would say, well, no, my experience actually doesn't agree with that. My experience is more consistent with the kind of story that I just read as a real experience than what you may think. So, of course, there's plenty of reaction to these kinds of things. There's lots of skeptical comments that basically say that there are billions of people out there with trillions of experiences, and so we hear the weird stuff. Occasionally there's going to be an unusual coincidence, and those are the things that bubble up to the top. And so while the experience that I just read, which is a true experience, maybe it's a 1 in a trillion chance, but it's because there's all these other experiences that we don't hear about. So that's a possible explanation. It's probably true to some extent. And there are lots of other explanations that can be used to look at stories like this and try to understand why is it that people have these experiences. On the other hand, it doesn't take very long to realize that popular culture is saturated with this topic. It forms the base of an enduring topic that almost everywhere you look, within novels to TV to you name it, there's something out there all the time. It's a compelling topic. And so the question is, why is that? And I would say that one of the things that we run into again and again as a scientist studying this is a taboo. Well, the taboo in science, as it does in any realm, it restricts the nature of inquiry. And it also restricts what ideas are acceptable. And as a taboo, this is not very good in science because science rests on informed consent or informed consensus. If an informed consensus is constrained because of a taboo, it means that science can't really make up a good decision about what's going on. It means that it also will create distortions in how the topic is reported, because especially among skeptical journalists, they don't want to be caught with their pants down. So it's extremely difficult to get accurate reporting on this topic in the science media, and I'll show you an example in a minute. All this means is that the taboo is sustained, and this taboo has been sustained for over 100 years, so it's a really good one. So this showed up yesterday on the Boston Globe. Brain scan tests failed to support validity of ESP. And the journalist said that research on parapsychology is largely taboo in academia, but now 2 Harvard scientists have set out to settle once and for all, does it exist? The study was the first to use cutting-edge brain scanning called functional MRI. Well, here's our first mistake, because in fact it wasn't the first, it's the 5th. And the previous 4, which you guys can find out very quickly now because of the nice Google Scholar engine, you can find 4 others published, 3 of which are in mainstream medical journals, of which all 4 of the previous MRI studies are successful. Have you ever heard of them? No. But this one, which turns out that it's not quite as unsuccessful as they claim, this one you do hear about. If ESP were real, the brain should have responded differently to ESP than to non-ESP, but they found, in all cases, no evidence for ESP. But that's actually not what the paper says. The paper says they tested 16 couples, of which 1 couple showed extremely significant results of the type that they predicted. But then they go through great pains to explain away that result as a possible artifact. In which case, my response, writing to this journalist, was, well, if you can take the results you're looking for and explain it away as an artifact, well, doesn't that mean that the study design was flawed? Because it means you potentially could have explained everything away as an artifact. And finally, the person who did this is a grad student at Harvard who got a prize for his best thesis when he was an undergraduate, looking at some kind of parapsychological effect. But now he's abandoning his interest because of professional peril. Well, that's the definition almost of the taboo. The taboo is that as a grad student, it's kind of okay to do this, but absolutely don't do it for your doctoral dissertation because the likelihood of going on to get a real job is much lowered. And that's because of the taboo, the topic itself. So my interest all along has been, like a lot of people, I've heard stories over the years. I'd never heard anything about this in my scientific training, but I was curious, could there be a there? Is there a kernel of truth in all of this saturation that we have in popular culture? Could there be something really going on? Well, we can't rely on anecdotes because they're not controlled, but there are scientific tests that have been controlled. Well, one place to look for what science has to say about this is to look for what scientific oversight panels have concluded. And during the Cold War, there were 4 open reviews and a number of classified reviews about what happens when you take people who are proponents and people who are skeptical and people in the middle, bring them together for a week or so to review the evidence. What do they conclude? These were 4 studies that were done that are in the open literature. All 4 concluded that something interesting was going on. They weren't willing in all cases to come out and say, yes, we believe that psychic effects are real, but they all did say, including the skeptics, something's going on that we can't account for. So here's an example of a review of remote viewing evidence that was done for the CIA in 1995, just as the formerly classified program became unclassified. Jessica Utz is a professor of statistics and also is now on the executive council of the AAAS. Her conclusion was that using the standards applied to any other area of science, it is concluded that psychic functioning has been well established. So Jessica is a world-renowned methodologist, besides being a statistician. One would think that she knows what she's talking about. The other person was Ray Hyman, a very well-known skeptic, professor of psychology from the University of Oregon, now retired. His conclusion was, well, these results, the experiments on remote viewing, were free of methodological weaknesses, and the effect sizes are too large and consistent to be dismissed as statistical flukes. So something interesting was going on. Now, Jessica and Ray disagreed about what to call this. Like, Ray is not going to say he believes in psychic phenomena no matter what. But nevertheless, in terms of the actual evidence, he agreed. Something interesting seems to be going on. So the bottom line is that if you begin to look at scientific oversight committees and review articles and so on over the past 130 years, you find increasingly sophisticated methods where effects don't disappear even under scrutiny with the latest techniques. So for example, I just mentioned the fMRI study. You can get results with an fMRI. Something interesting appears to be going on. Well, why didn't you learn this in college? Why don't you ever hear about this in the mainstream science media? It's because of that. It's this boo taboo. Some people think that there are no taboos in science. Like science is supposed to be open and freewheeling and so on, and of course this is not the case. There are 17,500 institutions of higher learning around the world. There are roughly 50 academics in the world who are openly interested in psi, and that includes both proponents and skeptics. 50, which means that the academic interest level is approximately 0.3%. 99.7% of all academia in the world don't have a single person identified for their interest, pro or con. That's a taboo. Well over 90% of the population is interested. About 60% of the population believes in the probability or the certainty that psychic effects are real. The rest of the population is interested. Some are very strongly against it. Others are sort of mildly for it. But the point is that a lot of people are at least interested. Usually for interesting topics, you have academic programs that are discussing it in some way. 0.3%. Why is that? Well, imagine that you can put consciousness on a continuum. And the bottom axis is where is consciousness? And we say, well, maybe it's local or maybe it's not so local. And the vertical axis, we say, well, what is consciousness? Is it something that is caused or something that is causal? Down here in the bottom, we have all is matter. It's a material monism. Under this model, the mind and the brain are identical. This is the assumption of the neurosciences. When you start moving up here, I don't want to restart my computer. When you start moving up on this scale, you bump into things that the neurosciences have difficulty in dealing with, things like creativity, intuition, and especially genius. If you look in the literature to find out what neuroscientists think about genius, and we're talking about Mozart-level genius, there is absolutely no response to that. We don't know how that can be. You go further up the scale towards non-local, you end up with things like psi, these strange experiences that people talk about. And then further up, mysticism, and now models that start to look like mind is not identical to brain. It's correlated with, but not identical. And all the way at the top is a mental monism or idealism. Well, here's Western sciences down here. It assumes that things are material, that we use objective methods, and the mind, in fact, is equal to the brain. Up here, roughly, is Eastern sciences, interested more in energetic or informational aspects of the world rather than material. Subjectivity is held in high regard, and mind is not equal to brain. So these two ways of looking at the world create theoretical boundaries. And you notice that I stuck psi into the Eastern sciences because it is compatible at that level. Whereas in the Western sciences, there's no room for it, and that's what sustains the taboo. From trained as a Western scientist, you look at these phenomena, and you cannot imagine any conceivable way that it can fit within the worldview that you were trained to understand. And obviously, that method is very powerful. You guys wouldn't have a job here. It wouldn't be no building here or anything if Western science wasn't extremely powerful. And so it's seductive in its power. But maybe Eastern sciences haven't been all that far off the mark either. So we both have our different tools. The tools in Western science have used fancy machines like an MRI to look inside the brain, to look at the material part of it. And the Eastern sciences are based more on contemplative practice, interior. And we both have our mandalas. Our mandalas in the West are these pretty pictures that come out of the brain, and the mandalas in the East are other kinds of pretty pictures. So in the West, when we look at that object and we say, well, how does that thing work? Our tendency is to take it apart, since that's what reductionism is good for. Well, what if it wasn't a brain that we were looking at, but more like that? It's this object. So from the West, we look at this object which is playing music. And so how do we go about understanding that? Well, the first thing is we imagine that there's music, there's somebody inside there creating the music. So we look for Led Zeppelin inside. We take it apart and we look for them, and we can't find them in there. What we find instead are circuits. And as our methods get better and better, we find that our ability to detect better and better circuitry gets better. And this is what we see in the neurosciences. Our pictures assume that we're seeing reflections of the thing which is generating the music. Somebody from the East would say, no, you've completely misconstrued what's going on here. The object is not generating music, it's receiving it. And now the important point here is that both sides might be right. What we see in the neurosciences are correlations. Well, even in the East, what they talk about are correlations that are going on, we assume the direction of causation based on our theoretical assumptions. So which one of these two are right? I'm not so sure. Does the brain generate the mind, or does the brain receive or filter out something about some large mind out there? Let's look now at experiences. These are the sorts of things that people report. On one end, you have mundane events that occur all the time. On the other side, you have profound events. And on this axis, how often they're reported, from common to rare. So we have things like this down at the common, mundane level. Most people report that sort of stuff. As you move up here, you start having things which have a much greater impact in terms of how it affects an individual and also whether or not they're rare, all the way up to mystical union. So who reports it? Everyone down here at this level of gut feelings, feeling of being stared at. Roughly 70% of the population, including populations of skeptics, will admit that sometimes they get gut feelings. Sometimes they have the feeling of being stared at. As we move up here, we start using different labels. And this is where, for scientists, your hair starts standing up because these words can push you, until you get even further up into genius and prodigy. And at this level, we start running into something interesting because we have the saints, the great scientists, great political leaders, and so on. And so up there, we have rare experiences presently beyond the reach of science to understand, but very well accepted. It's well accepted because those people and those ideas are what shaped civilization and shape history and shape science. And by contrast, the other end of this spectrum, we have common experiences that are completely amenable to scientific study, but it's highly controversial. I think that when presented in this way, it looks like a paradox, and it is kind of a paradox. And in fact, as I'll show you, the reason for the controversy really is the taboo. It is not the data. What are we talking about? We're talking about three kinds of ways in which information seems to flow. When information flows between minds, we call it telepathy. When it flows from a mind out into the environment in some way, we call it psychokinesis, or mind-matter interaction. If information flows from the environment into the person's mind, we call it clairvoyance, and if it slips in time, we call it precognition. That's basically the phenomena that we're dealing with. Well, the first rule in studying these kinds of effects is to recognize that human performance varies. You're looking here at the base hit rate for Mickey Mantle from 1951 to 1968. Well, how do you know that Mickey Mantle was a good base hitter? Because if you look at his overall average, it's basically 30%. That's good. To get at bat and 30% of the time actually get on base is exceptionally difficult. So we know that Mickey Mantle was good, even though on a year-to-year basis, his ability to hit actually fluctuated quite a bit. So human performance varies even at the level of expertise. The second is that experimental results will vary, which is a logical outcome of individual performance varying. And so this looks at 25 studies that were conducted to see whether taking aspirin prevents a second heart attack. No heart attack above the ratio of 1 and heart attacks below, and you can see that if you take the overall average, that it actually makes a small effect. It does prevent second heart attacks. The effect size here is really small. So the first effect size, 0.03, I'll show you in comparison to some other things in a minute, but the 0.006 is the percentage of variance accounted for by aspirin preventing second heart attacks. 0.6%, which means 99.4% of the variance in these studies is not accounted for by aspirin. Nevertheless, even with a really small effect, it is real. Real, small effects are still real. If it wasn't for statistics, we may never know that, but nevertheless, that's what statistics are for. We can find that things are real. So here's an example. Some years ago, silicone implants, breast implants, were removed from the market because sometimes it caused connective tissue disease. The effect size is less than 0.00. The amount of variance accounted for is less than 0.000, really tiny, and yet real enough to be taken off the market. Another example is aspirin, which I just said. It prevents heart attacks, but the effect size is really tiny. But still real enough for bare aspirin to get approval from the FDA to be able to say and sell aspirin. A lot of people take aspirin now to prevent heart attacks, to thin the blood, and so on. Aspirin can reduce the risk of death if taken as directed by a doctor as soon as a heart attack is suspected. That's on the basis of really small effect sizes, but real. By comparison, telepathy experiments have an effect size which is 5 times greater. And somehow that's not considered real. And the fourth rule is many experiences are, in fact, not psychic. So when a skeptic will say what these anecdotes that we hear are the result of selective memory and wishful thinking and coincidence and misperception and so on, all of that is completely correct. And in fact, if you do a survey, if you take a whole bunch of case studies and you start winnowing out the ones which are probably due to these kinds of effects, you'll probably get 80%, maybe a little bit more. But it leaves a residuum of roughly 10 to 20% of cases where you cannot explain why these effects are there. And it's not these sorts of things. So how would you test for telepathy? So the typical case of telepathy is something like that. Somebody is thinking of somebody else, even if they haven't thought of them in a long time, and the other person just, a fleeting thought goes to their head, I wonder why this person's thinking of me. This sort of thing is reported, and actually Rupert Sheldrake has been studying specifically telephone telepathy, which is the idea that the phone rings, you pick it up, and you haven't looked at the caller ID, and you just know who it is. It happens more often than you might think. So the way this has been studied in the laboratory is through a method called the Ganzfeld. The Ganzfeld is a German word meaning whole field. And so what you do is you'd have a sender and a receiver. The receiver, you sit down and you put them under a red light, and you take 2 ping pong balls and cut them in half, and you put them over their eyes, and you ask them to keep their eyes open. Now you can imagine that if you're under a red light, your eyes are open, but all you can see is a uniform redness. Then after a few minutes, your brain starts to get starved for information, and you begin to project hallucinations, visual hallucinations. Let's see. So you also want to encourage people to get audio hallucinations. So you put white noise through headphones, and you have them wear headphones, and they sit in a comfy chair. And after 15 minutes of this kind of stimulation, unpatterned stimulation, you begin to hear things and see things, very much like in a dream state. And that's the purpose of this method, to put somebody in a near dream state very quickly. And now you isolate them from the rest of the world, and you get a sender, and the sender's task is to think of something and try to inject those thoughts into this person's experience. And you encourage the person to speak aloud. The technical term is to mentate. They're mentating whatever's going on inside their head, and the mentation is taken by a one-way audio link back to the sender to help the sender revise their mental sending strategy so that the other person will begin to get what the person is sending. So how do we choose a target? The target is chosen randomly from a pool of targets which are as different from each other as you can get. So in this case, we might have randomly chosen a target of an elephant. So the sender sees an elephant, and then I was trying to think elephant-like thoughts and inject it into the mind of the receiver. And if you're lucky, the person will start talking about things like big animals and maybe Africa and so on. After about 30 minutes of that, you take the sender, the receiver, out of the Ganzfeld condition, and you show them 4 targets, and you may play back to them anything that they said, so that they may have been talking about a big animal in Africa. And now you simply ask them to choose which one of these 4 best corresponds to their experience. So by chance, they will choose the right one 1 in 4 times. And so we've collapsed an hour's worth of experiment into a single data point. And we do this for statistical reasons and also for clarity. The chance of getting it right is 1 in 4, 25%. These are places that have done this kind of experiment from about the 1920s until today. The cumulative results of somewhat over 3,000 such sessions from about 25 labs around the world. There's chance at 25%. The actual hit rate is about 32% cumulatively. And the error bars show 1 standard error. 88 experiments, the odds against chance are 29 quintillion to 1. This topic has been discussed in great gory detail in the technical literature and also in Psychological Bulletin in a couple of articles. Well, this is all subjects combined. Of 3,000 studies, typically college sophomores, people who are available, interested, just anybody. But if you look at special populations, in particular creative populations, or siblings, or people who have very high openness traits, which is a psychological trait, or have reported previous experience with things like telepathy, you find that their hit rate is not 32%, but it's actually way up here. It's more like 65%. So what kind of explanations are possible here? Besides the real telepathy explanation, you have things like it was a recording mistake, randomization problem, sensory leakage, on and on and on. The one that's been looked at that in most detail is the possibility of selective reporting. Because maybe there are 3,000 known studies, but there's 50,000 unknown studies, and if you stirred them into the mix, then it would all go away. But as it turns out, there are ways of testing or in estimating how much missing data there actually is. And I'm not going to go into it because that's a whole talk unto itself. But the bottom line is that selective reporting is not a plausible explanation for the results that we see. What happens when people review this data? Well, in 1985, Chuck Honorton, who was one of the principal researchers, did a meta-analysis, and he concluded that the results looked like there really was telepathy going on. In 1985 also, Ray Hyman, who we've already met, looked at the same data, and he concluded no, he wasn't convinced. 10 psychologists and statisticians were then asked to comment on both what Hyman and Honorton had written, and none agreed with Hyman, including 4 people who had no previously known opinion about the topic. In 1994, Darrell Bem and Chuck Honorton published in Psychological Bulletin, and they concluded, yes, something was going on. 1999, Milton and Wiseman published another meta-analysis on new data which had been collected up to that point. What they reported was no, I say here, they reported as no, but it turns out that their analysis is incorrect. If they used the same analysis, a very simple analysis based on hits and miss, as everybody else had done, actually they did find a significant effect. 2001, Storm and Ertel did another update, yes. So the bottom line here is that when you go through the meta-analyses that people have published, the only person who wasn't convinced was Ray Hyman. At bottom, what typically happens, though, is you say, well, meta-analyses have their own problems. What happens when skeptical researchers try the same experiment? 2005, this very interesting article was published in The Humanistic Psychologist by 2 skeptical psychologists who did 8 Ganzfeld studies of the type that I've just described. And after 8 studies, we had an overall statistically significant hit rate of 32%, which turns out to be exactly the same overall hit rate that you find in the meta-analyses. They then said that, well, this was precariously close to demonstrating that humans do have psychic powers. So they ran one more experiment using an ad hoc model of how they think psychic stuff would work, which no one had previously tested, and they got a significantly negative result on that one study. So they concluded that due to this last data set, we do not believe that humans possess telepathic powers. Further, the approximately 32% correct figure obtained in an enormous number of psi studies remains perplexing. Perhaps this 7% phenomenon is comparable to Meal's crud factor. So I wrote a letter to the editor saying, well, I'm not sure that crud factor is actually a very good explanation. But what it does do is, again, show a very clear indicator of the kind of taboo that we're dealing with. Because if you come into this as a skeptic, you run 8 studies, you get an overall significant result, which is the same as everyone else has been reporting. And then you're compelled to say that, well, this is precariously close to demonstrating something I don't believe. Well, why do people do that? I would have stopped after 8 studies and said, well, looks pretty good to me, but some people are not willing to do that. To which I respond, if they don't like our evidence, I'll show them the kittens, because everybody likes kittens. This expresses some of my frustration and the frustration of my colleagues who, after showing a huge amount of evidence, which is reasonably consistent over long periods of time, you can't convince people if they don't like the kittens. So sometimes you have to bring them out. If all of the preceding was true, then it probably is also true that there should be correlations between people's brains who are isolated. And so you can do an experiment of the following type. You have to take 2 people, you isolate them, you have them think about each other, you get some sort of a light flashing stimulus to create evoked potentials in one person's brain, and you look in the other person's brain and see whether you get an effect. Very simple. So here's how we did it up at the Institute of Noetic Sciences. We have our fancy shielded room. We put the receiver in there and measured a single cortical measure at CZ. The sender is at a distance. The sender's room is normally dark, but for the purposes of taking a picture, it has a flash here. So she's in a dark room looking at a blank screen, and every so often, the face of the other person pops up for a few seconds, and then it goes away. So that does two things. It does a visual stimulus. It creates a light flash, which will create an evoked potential in her brain. And it also reminds her what the nature of the task is, namely, you're trying to connect to your friend at a distance. So the experimental data looks like this. This is based on 13 couples. The sender's brain gets a big evoked response just about at the right time scale that you'd expect. And the receiver's brain also showed a peak at that point. If you do a correlation and do the proper statistics, you end up with a statistically significant correlation in time between the two brains. Now this is, the sender's brain, of course, is completely expected. The receiver's brain is not, because the receiver is sitting in a dark room and nothing's happening. And by the way, the receiver never reports anything either. In this case, the receiver is not reporting seeing weird flickering lights or anything. She reports nothing. Well, this was published, another study was published by some colleagues at the University of Edinburgh where they looked at overall level of activation in the brain using a topological map. And you can see here that when the light flashed, let's see if it points it, yeah. So the light flashes here, roughly 200 milliseconds later, there's a lot of activity in the brain and sort of dies away. What's happening in the composite brain of the receivers? As it turns out, there's an interesting activation that rises in the receivers, which peaks around 200 milliseconds as well. Again, the receivers don't report anything here. This is all unconscious, but nevertheless, their central nervous system is running in time sync, apparently, with what's going on in the senders, and yeah, the senders. There are lots of other studies of this type I could talk about, but I'm going to skip over them and go directly into the other fMRI studies. So here's a study done by Leanna Standish and her colleagues up at Bastyr University and Washington University. They did a study involving 30 couples who had been selected for having practiced a dyad meditation. This is when two people meditate with each other and on each other. So they'd been practicing this for a long time. They took those 30 couples, ran an EEG study, and selected the 3 top couples who seemed to show an EEG conduction, and then ran the top one of them in this study, in the fMRI. So this is one couple pre-selected out of a group of 30 people. And what you see here is in the receiver's brain, while the sender at a distance is looking at a flickering checkerboard pattern, that the occipital lobe, and in particular the visual cortex of the receiver, lit up in time sync and to a highly significant degree. So that was published in 2001. As far as I can tell, it was never reported anywhere other than in the journal. Like no science media picked it up. This was repeated a few years later with the same couple. Richards is at the University of Washington. Again, the same couple, this time in both of the pair. They would run the pair, first one as receiver, one as a sender, and then flip them. In this case, both of them showed an effect. We're going to jump now to something completely different. What we've been talking about is the possibility of telepathy, which is consistent both in terms of conscious report and central nervous system reports, and also, it turns out, autonomic nervous system reports. There's a lot of data suggesting that people connect with each other in some way that doesn't look like ordinary physics. Well, what about the color phi effect? This is a well-known effect in visual perception. If you look on a time scale where you have a blue dot, and a little bit later you have a red dot, and you just loop around and around. So you're seeing blue, red, flashing back and forth. And you ask people, what do they perceive? What they perceive is that the blue dot, about halfway through, changes into a red dot. And this is an interesting illusion because the conscious experience precedes the actual stimulus itself. So what could account for that? Well, Daniel Dennett says this about the color phi effect. Unless there's precognition in the brain, this illusory content cannot be created until after some identification of the second spot occurs in the brain. And so it leads to ideas like tape delays and retrodiction and words that say that the brain is able to backward infer what happened. Unless there really is evidence for precognition, in which case this changes interpretation quite significantly. So I call presentiment an unconscious form of precognition, a feeling about an event in the future, or a vague sense of impending doom. Here's how you do the experiment. You sit somebody down in front of a blank screen, and you record some measure. I typically have used autonomic measures, but as you'll see, you could use other measures as well. Skin conductance is a good one. They press a button. 3 to 5 seconds goes by while the screen remains blank. The computer randomly selects one picture out of a huge pool of pictures. And the computer just shows the picture for 3 seconds. It's either calm or it's emotional. And then the screen goes blank for a while to let the person calm down. And then you repeat this 30 or 40 times. So the whole experiment is over in 20 minutes. The pictures that I've used most often are called the International Affective Picture System. These were developed for the NIMH at the University of Florida. And there's an international standard of pictures that evoke emotion and to what degree they evoke the emotion. So examples are this. This is a low affect picture, non-emotional picture. This is a positive valence, high emotion picture for certain people, and the same for certain other people. And then there's also a negative valence, positive or emotional. And in each category here, they go to extremes. So in the really extreme case of a negative emotional picture, these are pictures you really don't want to see. When they get in your head and you sort of wish you hadn't seen them, it's that kind of a picture. Not so much on the erotic side. On the erotic side, you look at the pictures and you really want to see them again and again. That's a different story. So here's what the actual data looks like. This is skin conductance in somebody who saw a sequence of calm pictures randomly selected. So they might see a picture like that and a picture like that. And as you see, there's a certain degree of anticipation, waiting for the picture, you see it, and then they relax. And this happens again and again. But this is a real case where an emotional picture arose. And the presentiment then is this anomaly, that there is a greater degree of anticipation before that one picture than there was before the preceding pictures. So when you do this as a formal experiment, you end up with something like this. This is the average of all of the emotional pictures before, during, and after it was shown. And for the calm pictures, here's where you press the button to begin the trial. Here's where the stimulus is randomly selected. So when you press the button and your weight and your physiology is being recorded, the stimulus has not been selected yet. It's still in the future. That difference is a presentiment difference. It suggests that there's something about the future which is pulling your present. And so you can do a statistical analysis. In this case, one person with 30 trials ended up with a statistically significant difference, suggesting that somehow they knew what was about to occur. Starting in 1995, I guess, I started running a series of studies. This was one I ran here in Silicon Valley when I was working at Interval Research. This is the button press. Here's where the stimulus occurs. There's the presentiment difference, which turned out to be highly statistically significant. And most of the participants in this test turned out to be people like you, because I was working in an environment very much like this, and I needed subjects. And I basically would walk around and say, oh, they have 20 minutes to spare, and found people to do the test. So overall, I did 133 people, about 4,500 trials, and got a statistically significant effect along the line suggesting that there's something that is giving you a cue about what's coming up. So what sort of explanations can we use for this, other than precognition? Well, it is a long laundry list. As in any experiment of this type, we always go through alternative explanations that are more conventional. And so you go through all of these, and it turns out that none of them are very plausible, partially because of the way we designed it, also because of the way we analyze it, and even more explanations. The bottom line always is it independently replicable? And the answer is yes. Shortly after I presented my first study, Dick Bierman at the University of Amsterdam did an almost identical study using his hardware and his people, of course. And he reported basically the same kind of result that I did. He didn't actually think it was going to work, but did it anyway and got an interesting result. This was then repeated. Oh, well, there was a significant result. This was repeated by Chester Wildey at the University of Texas. He's an electrical engineering student who built his own skin conductance meter as part of his master's thesis and then used it for this experiment. And there's the presentiment difference. He also used both people and earthworms. Yes?
P number. I'm trying to figure out what the relationship between the P number and the graph.
The P number is a probability of the result.
The second result on the graph?
Well, in these particular cases, of that the difference highlighted in yellow is due to chance. This is not the way a statistician would report it, but in a popular way of thinking of it, it's the probability that the result you're looking at is chance. So if you get a probability which is really small, it's very likely not due to chance.
Oh, I see. So P less than 0.003 means there's a very low chance.
Right. That's right. So Chester did this study with people and earthworms and got an almost significant result. Significant here, by the way, is by convention in behavioral science is 0.05, is at the threshold where you start to think something's going on. And it's a completely arbitrary number, but nevertheless, it acts as a kind of a magic icon within the behavioral and social sciences. So we got a 0.06 result. Then my colleagues Ed May and James Spottiswoode did a study using simply audio startle tones. You'd sit there with headphones on, and about once a minute you'd hear a real loud noise, randomly. And sometimes you'd hear nothing. And so this is looking at the difference between hearing sound and hearing silence, and they got a significant effect. This is 125 people that they ran just once, just the first time. This was then repeated by a colleague of his in Hungary, using new equipment, new population, so on. Again, a significant result. Rollin McCraty at the Institute of Heartmath in Boulder Creek did the same kind of study using pictures like I had used. He found similar results in heart rate, which is his main interest. So there's a stimulus, two different conditions before and after meditation. Those yellow areas are both significant. And then, let's see, what about presentiment in the brain? Most of what we've looked at so far is presentiment in the autonomic nervous system. It's partially because it's easy to measure there. But what about in the central nervous system? So we did an experiment where we looked at presentiment in the brain in a very simple test where you basically sit down in a dark environment, you wear glasses that have LEDs in them, and every so often they flash. In fact, you're asked to press a button. Let's see. You press a button, and you know that 4 seconds later you will either see a flash or you won't see a flash. That's the nature of the experiment. And each person did 100 trials. The flashes are determined completely randomly using a true random number generator. So this is the results shown for women. This is the median EEG in the two conditions. There's where the button is pressed. There's where the stimulus occurs, which is either a flash of light or no flash. That difference, 1 second before the flash, and remember, in all of these experiments, the stimulus is determined immediately before it's shown. So the physiological result that you see here is happening before the stimulus has been determined. It's not like it's a clairvoyant experiment where somebody knows what the answer is. Nobody knows what the answer is. It's determined on the fly right before it appears. So the women in this experiment got, that's the interesting result, they got a significant result, two-tailed, and the men did not. Men got a 0.12 probability. So interesting, but not significant. Well, here's something that looks kind of similar. There's a stimulus. There are 3 different kinds of pictures, calm, violent, and erotic. For both the erotic and violent pictures, there was a rise, a presentiment type rise. Females got a significant result for both erotic and violent, and males for erotic pictures only, which you see actually fairly often in this. Males become inured to pictures of violence. And we also have a different reaction. When we see a picture of violence, we sort of shut in. We don't get all emotional about it. Females in general don't act that way, and you just actually see it in these results. What we're looking at here is not skin conductance, but we're actually looking at hemodynamics. We're looking at an fMRI. So even in an fMRI, you can do this study, and you can see where is the effect showing up in the brain. The primary effect showed up in the visual cortex, which is not too surprising because we're dealing with visual stimuli here. But nevertheless, there's something different in the brain, in the visual cortex, if you're just about to see an emotional picture versus a calm picture. This, by the way, was the 4th fMRI study looking at an ESP phenomena. What about in pupil dilation? Pupil dilation is a very interesting thing to study because it reflects a balance between the two aspects of the autonomic nervous system, between the sympathetic and the parasympathetic. And if you ever look at your eye, you can sort of see it fluctuating a lot. The fluctuation is showing the balance between the ambient light, but also whether your sympathetic or parasympathetic part of your nervous system is more dominant at that moment. So it turns out to be a really good lie detector and a really good way of seeing how people are responding emotionally to what they're seeing. So we do this experiment. We did this in the lab with a nice little eye tracker. And what you can see, the experimenter can see what she's looking at. So I saw that she's looking at this picture, and I see how big her pupil is, and I also know exactly where she's looking. And we get 60 samples per second on this. So using the same kind of designs as before, we have emotional picture average on the top, the calm pictures on the bottom. We get a highly significant result. This was based on 36 people. Most of the result turns out to be in women, not so much in men. This is a very nice study to do with an eye tracker, because one of the problems in doing eye tracking research is that the amount of illumination in the picture itself will cause a pupil to change. If you have a bright picture, people get stopped down. But all of the action that we're interested in is while they're looking at a blank screen. So they're always guaranteed that while looking at the blank screen, that's where we want to see whether there's a difference in their pupil dilation. And it turns out that there is, exactly the same sort of response that we saw in the other measures. So the summary for presentiment studies, these are fairly new kind of study. I know of 19 done to date, of which 10 are significant. For 10 studies to be significant out of 19 is whoppingly significant overall. I mean, something interesting is going on. What about mind-matter interaction? Well, this is about a 2-hour talk. So all I can tell you is that this kind of phenomena has been looked at in great gory detail. Everything from random events, properties of metal, bacteria, plants, animal health, animal behavior, animal intention, human health, human behavior, human physiology, water, food, and photons. Most recent study is individual, or actually small groups of photons under conditions where you're doing the equivalent of a double-slit experiment. And you want to see whether or not there is the equivalent of a quantum observer effect, except without looking at it with your eye, looking at it with some kind of internal, intuitive eye, where you ask somebody to imagine that they could see something happening at a distance. As it turns out, this article was published today. I've been waiting for this to come out. It's Explore is an Elsevier journal. I wrote this in terms of testing intuitive knowledge. And the intuitive knowledge here is, if you may know that within a double-slit experiment, if you gain, or any quantum optics experiment, if you gain which path information about where the photons are going, you'll always see something that looks particulate-like. And if you don't get that information, you'll get interference patterns. You'll get things that look wave-like. So this experiment was one to use a double-slit type of design, actually used a Michelson interferometer, where I asked people to use their intuitive knowledge to gain which path information. Put your eye at a distance, in the apparatus at a distance, and gain which path information. Try to see the photon. And then we looked at the interference pattern to see what happened. And it turned out we got a significant result. So you can look that up today. Extraordinary claims require extraordinary evidence. I agree with that. But extraordinary with regard to what is the question that usually doesn't come up. Are psi experiences extraordinary? Well, no. It permeates culture, history, all educational levels. About the same number of college professors, when asked about their belief in psychic phenomena, is the same as the general public. You'll get a different response if you ask them to say aloud what it is, but if you do anonymous surveys, you get the same result. Is it extraordinary in terms of empirical evidence? I think the answer there also, it's not extraordinary. We're seeing repeatable, converging evidence over a long period of time suggesting that some of the things that people talk about are probably real, not all. What about extraordinary with regard to theory? Well, here, with regard to what many people imagine as Western science theory about what's allowable, yes, it looks like it's extraordinary. But on the other hand, are existing theories complete? I don't think so, at least I hope not. And if they're not complete, it leaves open a plausibility door. Well, maybe we'll learn something new at some point, and then it will no longer be extraordinary. What about an ontological view? Again, this is our worldview. How do we think the world is actually constructed? I would say that psi is compatible with what we've learned about non-locality in physics. This doesn't mean that I automatically will equate quantum entanglement, for example, or non-locality with psi. But what I do say is that it opens the door. It creates a vector pointing in a direction which is consistent, which is at least allowable for these phenomena to occur. And one of the things that non-local phenomena has done is take our previous classical worldview and really expand it a lot. And it has expanded it so much that most people who are not deeply involved in understanding what non-locality means just don't think about it. It's very difficult to think about these things, especially since non-locality is not just in space, but in time as well. So we live in a weird fabric of reality which has connections that both transcend space and time. So I would claim that psi claims are actually pretty ordinary. They certainly happen often enough. We can dismiss maybe 80 to 90% using the usual cognitive biases and coincidences and so on, but we can't dismiss 100%. And I go back to what Jessica Utz said, that using the standards applied to any other area of science is concluded that psychic functioning has been well established. And one thing that Ray Hyman agreed to with this statement was, it is, for at least for remote viewing, and he probably would agree for telepathy tests as well, there is no need to do additional studies that are proof-oriented. We have enough proof-oriented studies. What we need now are studies that are trying to get more at the question of why do we get these anomalies? Is it really psychic? That's hard to say because we don't know yet exactly what psychic means. But we see the results in the experiments that look a lot like what people report in real life. Well, why does any of this matter? Well, one reason is that I think it's just interesting. My personal reason that I've spent the last 25 years doing this as a scientist is because I think it's curious. It's very curious. Why would you not want to study this? Another thing is that I think it enhances public interest in science. When you have something where 90% of the people are interested in a phenomena, but the mainstream reaction to it is essentially, you're stupid. You don't understand how science works. That creates the kind of context where people get turned off by science. And you see in the NSF and other places that are concerned about literacy in science among the US population, everyone is concerned because people believe all kinds of weird stuff. Unfortunately, these phenomena, which are empirically testable, are lumped in to weird stuff in general, which I think is not warranted. This, in some respects, augments who and what we think we are. If telepathy is true, it means that what you think of as private thoughts aren't so private after all. It means that you have to think of your mind as mostly located in here, but spread out a little bit in both space and time. And if it's spread out in space and time, it means that your thoughts and other people's thoughts commingle at some stage. That creates a very dramatic change in terms of our personal ontology about who and what we think we are. Another thing is that it challenges the worldview that says we are completely isolated, we live in a mechanistic world where mind is brain, and a completely pointless existence. You see this sometimes for people who have been into the neurosciences for a while, especially as students. They become really depressed because the worldview that is presented is you're a meaningless zombie. There's nothing going on and everything is pointless. There's no meaning for anything. Or as Francis Crick wrote in his book, you're nothing but a pack of neurons. Well, my sense is that the neurosciences are correct. They're just not completely correct. And if it's not completely correct, what's the part that's missing? Am I nothing but a pack of neurons plus something else? Well, if so, I want to know what the something else is. And here's why science reacts badly to anomalies. Because what I presented to you from a Western science point of view are anomalies. What you see is an anomaly like here's some kind of weird result having to do with attention and physiology. And here's another weird result of attention on photons. And here it is on random events. And there's telepathy. Well, what do you do with this stuff? Well, you don't know what to do with it. There's another one, EEG correlations. But if I showed you a way of thinking about it, and you looked at this for 10 seconds, and now you look at the same pattern, now you can't not see the explanation that I just gave you. In fact, if you see this 10 years from now, you'll still see the couple dancing. So once you have a framework for a way to begin to take what looks like anomalies. And what I'm talking about here basically is a combination of theory and probably an expansion of our worldview, that all of this stuff will make perfect sense. And the frustrating thing for me is that we know historically that when anomalies arise, and they precede the theory, that once the theory arises, everything falls into place and everybody instantly forgets that it was controversial. It's like it's some sort of weird cultural amnesia, that you forget that things which we accept now were once so controversial that it got people burnt at the stake or equivalent. So for more information on all this stuff, these are books I recommend. My two books on the left. There are a bunch of other books. I brought 6 copies of Entangled Minds, which came out last year, or 2 years ago now. Conscious Universe I wrote in '97. They complement each other. Extraordinary Knowing is a view of these kinds of phenomena from the point of view of a psychotherapist, who I thought did a very good job. Parapsychology and the Skeptics goes into much more detail on how skeptics have responded to these issues over the past century or so. Irreducible Mind is a great book which looks at, is the neuroscience assumption that everything is reducible down to neurons or below? Is that viable? And they make a very strong case, I believe, where the answer is no. And just the one example I gave was genius. No one has any idea how to explain genius. Outside the Gates of Science was written by a science fiction writer who tried to take his standard skeptical approach as a journalist and a science fiction author to this phenomena. Could it be real? And you can see as you read through the book that he goes through enormous amounts of churning in his head to come out with some kind of conclusion, and he concludes that he thinks it is. It does look real. Psi-Wars is a combination of skeptical and proponent essays from the Journal of Consciousness Studies, and Varieties of Anomalous Experience was published by the American Psychological Association and includes psi as one of these strange anomalies that happens in the mind. And so I'll end right there. And I don't know, do we have a few minutes for questions? Okay. Questions? I'm going to put this one back up so you can look at that. A question in the back, yes.
Yes, I'm thinking along the lines of actually going forward with the science, going forward in this area and talking about technology, like being able to actually use these phenomena to do useful work, and especially like we usually think that there are actually existing people who have learned how to harness these things. So I'm wondering, have there been any studies which try to find people with extraordinary abilities and observe them and try to quantify what they do, that kind of thing?
Will that question be heard, or should I repeat it? Repeat it? So the question is, to boil it down, have technological demonstrations or uses of these phenomena been tried? And the answer for technology in the form of computing technology, probably not. I've been looking into that issue for a long time. So one of my degrees is in electrical engineering, and so it immediately comes to mind that maybe you can create not a brain-computer interface, but a mind-computer interface. I think something like that is possible, but we're not quite smart enough yet to figure out how to do it. But in terms of other kinds of technologies, like the use of remote viewing for psychic spying, or for archaeology, or for those sorts of things, that has been used successfully and continues to be used. So in terms of a skill, yes, there are practical applications. In terms of technologically augmented skill, as in what the DARPA is doing for augmented cognition, I don't think we're quite there yet, but we're getting close. And part of the reason that we're not closer is because we really don't yet have a good theory about what exactly is going on. One, just to show how difficult the problem is, there is some inkling that environmental factors strongly influence these effects. So James Spottiswoode and now a few others have looked at the role of the geomagnetic field in people's performance in these kinds of tasks. And it turns out that the geomagnetic field makes a big difference, a huge difference. Possibly the lunar cycle does as well. Of course, the lunar cycle and geomagnetic field are linked. Possibly the local sidereal time also makes a difference. So these are all physical correlates that seem to modulate these effects. It shouldn't be too surprising because those same variables also modulate other aspects of human behavior. So maybe we're looking at something which are effects which modulate the nervous system's ability to attend. And if we can figure out ways of optimizing that, well, maybe we can get effects which are strong enough to be able to be used in technological circumstances. David, you had your hand up.
Test. Is this on? No?
I guess
All
not.
So I apologize. I arrived a little late, so if you covered this earlier, I apologize. But I saw 4 experiments, the Ganzfeld, the EEG correlation, presentiment, and the last one, the interferometer. And it seemed to me they all shared some characteristics, that they could be repeated, that they had an outcome that could be predicted ahead of time, and that outcome is statistically different from chance, and that there is no rational explanation for that outcome. Do you agree that they meet those?
Well, yeah, that's how most experiments are set up. Not so much that there's no rational explanation, but yes.
That we know of.
Yes.
Yeah. So it seemed to me that any one of those 4 could easily win the James Randi $1 Million Prize for establishing psi phenomena, and therefore get a foothold in the establishment to further investigation of these. So why do you think that in the 10 years nobody has won the prize or even tested for it?
Well, as Ray Hyman said that no scientist would ever accept a phenomena based on one shot. So that's one reason. So as a scientist, perhaps, but as I showed here, that because experiments vary and human performance varies, that you have to do a power analysis to find out how many trials you need to do in order to be able to get a result at a certain effect. So I went through this exercise. How many trials are necessary to get an effect which would convince somebody to hand over $1 million? You probably need a probability, maybe 1 in 100 million, to get that. And if you want, say, a 90% or 99% chance of getting an effect that's 1 in 100 million, and you do the power analysis, it turns out that it would take somebody roughly 4 to 8 years of running these experiments every single day in order to get a result which would reach that level. And if you calculate how much money you need in order to do that, it turns out it's more than $1 million. So the answer is, it's not a cost-effective challenge. The other thing is that the reason why I don't like challenges that are open-ended, I mean, this is a very different kind of challenge than the first private or commercial rocket that goes a certain distance. It's a very clear challenge. You know in advance what you need to do.
Would you be willing to try for that prize?
Absolutely. Yep. And by the way, it's not the case that, not me, but some colleagues of mine have actually suggested that the presentiment experiment would be an interesting one to use for this because it seems to have a pretty big effect size. The challenge went out, no response ever came back. So, you know, what do you do? Yeah.
So if it's like you say, I mean, you were saying earlier that you're not sure whether this is based on quantum entanglement, but if it is, I guess one thing that you could expect is that people who are entangled that way, maybe their connection would tend to diminish over time. As, I mean, supposing that their brains interact with the environment, which I guess they do, you know, you would expect, I guess if you were like entangled particles, the brain because the quantum state is collapsed.
Right.
So is that an effect that you observed?
Well, the question is on whether, if there is something maybe analogous to entanglement between brains, would it decline with time? And I think the answer probably is yes, it would. But on the other hand, the kind of entanglement that we're working with here is a dynamic entanglement. If you use as a metaphor something like entanglement, and you're dealing with people who you're with a lot, you're constantly being re-entangled. So you can imagine something like people you're very close to have a certain degree of entanglement. I'm not talking quantum entanglement, but some sort of psychological entanglement. People you don't tend to be around very much with, you have a smaller degree because it decays. People you're never around at all, you might have some because of some background entanglement resulting from the Big Bang, but it would be really tiny. So that kind of a model can be used to predict that when people report telepathic type experiences, they ought to be stronger among the people you know the best and a little bit less and so on, and that is, of course, what you see. So, was there a question? You had a question.
I recently saw a talk by Ken Miller about the connection between science and creationism. And he said something that I thought was very smart. He said that one of the reasons why scientists don't like this argument that all evolution is a theory is that theories in science are regarded entirely as facts. So because theories explain facts, and facts just sort of these things that happen. So all the experiments that you mentioned are factually very interesting, and they're statistically very correct, but they're missing a key ingredient of science, which is in the scientific method. You have to have a theory that makes a prediction, and then you make an experiment that could falsify the theory. And if there is an experiment, there is a prediction, but there is no theory in any of these experiments. So how do you think we could go about addressing that problem? A theory that explains why this happens.
Right. So the question is that one of the things that is part of the power of science is that they're both theories where you can make predictions, you do experiments, and so on. There's a balance between theory and experimentation. That's true for what we might call a mature science. But at the leading edge of science, the way that all sciences begin is somebody making an observation of a weird thing. And at that point, you don't have a theory yet. All of this is pre-theoretic. That doesn't make it not science. It's the beginning of science. It's where you look at repeated effects throughout history and you say, well, what do we do with this? The usual way that it's dealt with, which gives rise to the taboo, is to say, you know what, there's no theory, therefore that observation can't be what it appears to be. That's where theory goes wrong. It's like why theory sometimes is not such a good thing to come in on with. Because if you're carrying your theory along with you, it changes your way of perceiving the world, the way the world actually is. And if you look at the history of science, you see again and again, somebody reports a strange observation which is dismissed because it doesn't fit. And it takes sometimes 100 years for theory to have evolved to the point where now it's okay. So I give a number of examples of that in the conscious universe, and there are many examples where theory can act as a blinding force. So it also is a temperamental difference. I have friends who are basically theorists. They don't think about empiricism at all. And so they think in terms of explanatory, the world must be explained. That's what they're good at. I'm not a very good theorist. I've spent most of my career doing empirical things, looking at what the world actually is trying to tell me. And I don't really care that much about theory. The reason why my book is called Entangled Minds and why I talk about quantum entanglement is partially because of the question that you just said comes up so often, where sometimes people are not even willing to entertain the evidence unless there's some explanation. So I said, okay, I'll come up with something. Well, here's a good thing. Entanglement's good. You know, it sort of sounds like that. Well, maybe it's completely wrong, but nevertheless, at least gives some way of conceiving what's going on. And so in a sense, what I'm doing is challenging theorists by saying, well, okay, you guys, a huge body of data. It has a certain degree of internal consistency over a long period of time. We can make predictions that if we see it happening like telepathy and conscious experience, we ought to be able to see it in unconscious physiological states as well. So we go do the experiment and we see it. So the hope then is when I give a talk in a technical environment is to spark the mind of somebody who's thinking about theory all the time and have them think, well, okay, maybe there's microtubules in the head which are quantum oscillators and blah, blah, blah. And they come up with some kind of reason that would advance the state of the science. So I completely agree. We need theories. If anybody comes up with a good idea, let me know. Or publish it first. Yes?
So first of all, thank you for coming. It's certainly an atypical topic to discuss with this kind of audience. So I have a few questions. So I'm a little skeptical of the experiments that you gave, because I'm not sure what the environmental biases were. For example, in the experiment with the elephant, when you had the 4 different pictures, I feel like the bias would necessarily be the one where people would probably choose the first picture, and if people keep on choosing the first picture, they just assume that the first picture is not chosen. So I don't know whether or not randomization was...
Can I answer that? So, let me answer that now before you continue. In the case of the Ganzfeld, the order in which the pictures are presented to the subject at the end are randomized. So maybe it was the first picture, maybe not. So over thousands of such studies, the order should not make any difference. And in fact, when you look at the vast majority of studies of this type, it doesn't make any difference. And so that is tracked.
Okay, and my second question was for the one with the light. I mean, there is a possibility that the person on the receiving side can actually see the light. So I know it's impossible for me to tell from images. I mean, the theory is nice, but how do I know that it was actually the case where they
Well, that's a good question. It's difficult to convey in a sort of broad-based presentation like this what actually goes on in these experiments. I have a talk on the Ganzfeld alone, which is a couple of hours. And part of the midpoint of that talk talks about the due diligence that goes on to make sure that you're not dealing with an ordinary explanation, like a sensory cue, or like an electromagnetic pulse coming out of the stimulator device, things of that sort. This has been discussed to such great detail that you wouldn't believe. And one of the reasons that it's both that people pay attention to it and it's discussed in great detail is because of the skepticism, and rightly so. So people are saying, you know what, I'm not sure I believe this because maybe it was that. Imagine now 130 years of those comments. So somebody does one of these experiments now, you come with a huge long list of things that you have to nail down tight. Because if you don't nail it down tight, your colleagues will kill you because they don't want bad evidence going out either. So in the case of something like the Ganzfeld, how do we know? Well, besides being in rooms which are typically 10 to 30 meters apart, at least one of the rooms will be a Faraday cage, typically, like in our case, it's a double steel-walled commercial Faraday room. You do pre-testing, and you see if you make sounds, you make noise, in our case, we tested vibration, we tested audio tones, light flashing, a bunch of things of that sort, to see whether it's perceivable, either consciously or unconsciously, through physiological testing on the receiving side. And we're talking about tones, for example, from the sender's room to the receiver's room using a Coast Guard horn. So in the sender's room, we use a Coast Guard horn, which is over 100 dB. It's really loud. And you blast it, and you see if the other person can hear it. You make audio measurements to see whether there's any discernible difference. And the answer is no. But as we learned, you actually attract the fire department, because we were blasting the horn quite a bit, and the fire department came because they thought we were having a problem. So those are the kinds of hoops that we jump through. And in fact, one of the reasons we have a very fancy electromagnetically shielded room is exactly for the reasons of being able to describe to somebody, how do we know that there was no ordinary signal getting in? Well, that's how we know. We test it, and we use means that are known for getting rid of such stuff.
And then my last question is this, that my primary concern is that this is becoming dangerously close to correlation versus causation fallacy. Because I feel like saying that there's like a 0.005% chance that something happens states that, this unlikely event has happened, but I feel like you're going further and stating that because that happened, it means that there is a possibility of it being true. And I'm wondering how you address that or that exists or whatever. Again, I'm concerned about that issue.
Well, it is true. The results we see in these experiments, and in fact, almost all experiments in any domain, they're correlations. That's what we see. We infer the arrow of causation. In this case, I'm willing to take the next step and say that, yes, the experiments show correlations, but because we set it up in such a way that we think we know what we're doing, I will infer that the arrow of causation comes from that person to this person. But we don't really know that. So that is true. One of the reasons that we don't know yet which direction the arrow of causation goes, or, in fact, maybe there is no direction of causation. Maybe we're dealing with something which is a purely correlative phenomenon, which is possible. We don't have theories yet which would say that we should be able to predict that you'll get a correlation phenomena versus a causal one. That's what we're waiting for. So technically, you're correct. We're dealing with correlations. We know that the correlations are not chance. So something is giving rise to the correlation. When I do an experiment of this type, typically the way I assign the arrow of causation is because I tell somebody, I want you to do this. And then presumably they do that in their head. Well, that's one side of the correlation. The other person is very passive. They're sitting there in a dark room doing nothing. And yet their brain's sort of hopping along with what the other person is doing, who I gave the instruction to do something. So it looks like the arrow of causation is going from the person who I asked to do something to the other person. But you can't actually see that in the data itself. That's true. Yes?
You'll have to forgive me for using Google. It's a habit because I work here. But so I started reading about the Ganzfeld experiment. I found this long article from a paranormal researcher called Susan Blackmore.
who claims that she herself, performed the Ganzfeld experiment in the 70s and with negative result, with no result. And she went on to investigate the labs of some of the other prominent people doing that, and said that she found sort of severe methodological problems in lots of places that the experiment could break. So, and then she goes on to say that, it seems like that, designing this sort of experiment is actually incredibly hard because there are all these sort of gotchas about how the human brain works. So the young lady over there just mentioned that, sometimes people might pick the first thing, and sort of randomization is the answer to that. It may be that, for instance, I know that, at least according to this, some of the early experiments actually had interaction between someone who's actually interviewing the person who gets out of the chamber, and that person who's interviewing them is the same person throughout. So there would be visual cues from that, right? So for instance, I don't know if this is the way the experiment was actually designed.
It's not designed.
So the interesting thing to me is it seems like that this sort of beta statistical technique is really in serious danger of ignoring these sort of this type of methodological flaw. I don't know if it's true or not, but it seems like to me that reading these accounts of this and reading how complicated this experiment is, looking at a graph of sort of people who've done that result over time and looking at their results and then sort of lumping those together in sort of one cohort, it seems really dangerous. It seems like that, that there are a lot of...
Well, if you continue to use Google, you'll find other articles, and you'll find that this question has been addressed in great detail. And in particular, the studies that Sue Blackmore said that she found a problem with, which, by the way, was never proven, just her opinion, if you take those studies out, you get exactly the same result.
But all that says is that, if there is a methodological problem, it may be, sort of unique across all the experiments. I mean, I'm not saying...
But this is like a straw man argument that you can never get around. Of course, any experiment might have a problem. And the reason why we rely on independent replication is because we hope that people are not making the same mistake over and over again.
Wouldn't it be interesting, though, if you had two sets of experiments, and one of them you knew had methodological problems, and you somehow ended up with the same results from both of them, and you claimed that one of them was better? Wouldn't that be evidence that, that in fact there's actually an underlying sort of problem with the result?
Well, again, if you spend a little bit more time reading about it, you'll find that that question has been addressed as well. And this is the question about, is the quality of the experiment, the assessed quality, the methodological quality, related to the result of the experiment in a way that would make you predict that the better the experiment, the worse the results? And the answer is no. And so in other words, you can address, all of these questions have been thrashed out for so many years and in so many different ways that in virtually every case you can think of, there is a way of addressing either analytically or experimentally whether the result is what it appears to be.
I guess my skepticism is rooted in the fact that I understand that scientists are subject to taboos as well, but if the evidence is as strong as you say, it just seems like unbelievable that somebody else couldn't independently fund this study and sort of produce the same results. And I think that when I find this, it seems like that most of the people defending this are people who sort of have a dog in the fight, so to speak.
That's why I showed the results of the two highly skeptical professors who did the experiment and got exactly the same result.
Were they using the same experiment designed by the people who believed in paranormal phenomena? Using the same methodology?
According to their description, yes.
Okay,
and the experiment that they did that failed used a different method. And actually didn't fail, got a significantly negative result. So it's a valid concern of do people believe in a result or not? One of the problems with that as a criticism is you see this actually happening in the data. Somebody comes along who is skeptical. They do an experiment and it works. They publish it. They are no longer perceived as skeptical, which is ridiculous. I'm as skeptical as anybody else. In fact, you have to be skeptical, much more skeptical than you would imagine when you do these experiments, because if you're not, it'll be transparently obvious to anybody else looking at it that you made a mistake.
I guess that, everything I know about human nature indicates that there are fundamental biases inherent in believing something and going out to prove it. And we see this in sort of, famous scientific scandals. So, I guess, I can do some more research of my own, but I guess it sort of sounds like that it's awfully suspicious to me that most of the people out there pitching this are the people who already believe it. And it sort of seems like that there are people who start out with a belief in psi and then go to sort of conduct experiments to sort of...
Except, as I said, you have a very serious problem in that. Take myself, for example. Did I start out as a believer? The answer is no. There was no one in my family or myself who ever reported anything psychic. Had no a priori reason to believe any of it. It was only through doing repeated experiments where I began to convince myself through the data that it looks like something was going on. And if you then cast that out into a wider net, then it really does mean that you will end up with people who are converted, in a sense, by their own experience, by the nature of the data. And that's the camp that I put myself into. And the continuing distrust of bias and experimenters is a valid concern. And one of the reasons why I write and talk about this stuff is to try to interest somebody else to actually do the experiment. So just to give you an example, in 1994 in Psychological Bulletin, this meta-analysis came out that said that it looks like there's a real effect going on in the Ganzfeld. Now, James Alcock, who's a well-known skeptic, said, well, if there was a real effect going on, then the parapsychologists, who constitute a very small number of scientists, they would be trampled by thousands of people in academic psychology who want to go ahead and test this. And the result was a resounding silence. It is not the case that you can find lots of skeptics out there who are actually willing to go ahead and try these experiments. That's why I'm actually I'm very encouraged by the studies of the two folks that I mentioned that published an article in the Humanistic Psychologist, because they were extremely skeptical and remain extremely skeptical, even though they got the same results that everybody else reports. Here's the question.
So in the sender-receiver experiments, has there ever been, as part of those, a control where, say, there's a receiver but no sender? So you have the room with the TV and it's showing, the elephant image. There's nobody in there. Does the receiver still pick up an elephant image, 32% of the time?
There have been a few studies looking at the sender-by-sender condition. The results are ambiguous. It's not clear that one condition is better than the other. There is a smidgen of evidence suggesting that it helps to have a distant sender. And this, of course, is under a condition where the receiver doesn't know if there's somebody sending or not. There's a little bit of evidence suggesting that it makes a difference. The stronger evidence is among the EEG correlation studies, because there, what I've done and some colleagues have done is to look in the sender's brain to see if they actually have an evoked response. Because sometimes the senders fall asleep, in which case their brain goes to sleep too, and they don't show a response. So if you partition the data according to whether the sender is actually showing a response versus not, you get a positive correlation when they are responding, and you get no correlation when they're not responding, suggesting that at least in that kind of design, that it appears as though you can make the correlation appear and disappear by what is actually going on at the level of the sender. So that's one answer. Yes?
So I'm not a statistician, so you have to give me a somewhat late response to this question. On the one hand, you say, with regards to telepathy, you say that they're all, a vast body of, or at least a good number of very statistically significant studies, and yet, on the other hand, you told the gentleman in the front that it'd take 8 years of continuous study to actually show this effect. And you're asking us to believe this then on something much less than 8 years of continuous study. I've got to ask, what exactly does statistical significance mean?
The difference here is if you want to do a single study, if you're going for a prize and you need results of 100 million to 1, and you need to set up all of the conditions in advance, in order to get that, you can calculate statistically exactly how many trials you need. That would take a long time. It would take a lot of data to do that. What we're looking at in a meta-analysis, which is this accumulation graph that I showed, that's not a single study. That's a result of 30 years of other people's studies. And the value of the graph is that it shows that over time you begin to converge on a value. So that's like the general population value. But that's an open-ended experiment. That will keep going on as long as new data comes in. So the difference then is when you do a meta-analysis, you're simply asking a question of, is this seem to be real and is it repeatable? So we can tell that on the basis of these studies. It looks like the answer is yes, and we know how big the effect is. So now if we say, okay, we need 100 million to 1 odds in order to win a prize, you turn the crank and you come out with, well, what does that study need to look like? And you end up with a really big study, a huge study.
So of the studies currently done, if you take them, all combined together, what is the actual probability you currently have? Is it 10 to 1, 1,000 to 1?
Well, for the Ganzfeld, it's 29 quintillion to 1. 29 million trillion or billion trillion to 1.
So that doesn't seem like it should take 8 years of continuous study to really show the existence of this.
The difference is
so few studies.
it has to do with the concept of statistical power. If you have one chance to do this right, and there's a lot of variance in one study to the next, so you can't really predict very well if you're going to get a good result unless you have enough power, statistical power. So normally when you do an experiment of this type, you say, well, if we end up with an overall probability of, say, 0.05, we'll consider that a success. Well, you need far fewer trials for that. I mean, if you say with a 90% chance of getting a 0.05 result in this experiment, you need something like 600 or 700 trials. That'll take a little while, but it won't take all that long. But if now saying I want a 99% chance to get odds of 100 million to 1, that's a completely different ballgame. You need a huge amount of data in order to guarantee that you're going to get a successful result at that very low level of probability. So it's basically the mathematics that determine this.
I guess what I'm saying is 2 studies, each with 100 samples. I don't understand how that differs from 1 study with 200 samples. It sounds like what you're doing is you're taking a study that shows a very small probability, and you're saying because there was some probability, we'll treat this as 1. And you're getting the 29 quintillion number by summing up the powers that way. Whereas had you simply taken all the samples and done it, I think you'd find a number much smaller.
Turns out not to be so. I mean, just look into the statistics, and especially look up statistical power and read about it. And you'll see that the statistical power curves deviate very quickly as soon as your requirement for success goes up a lot. That's one thing. You require many, many more trials. You notice in the cumulative graph with 3,000 some trials on it, there was no a priori saying, well, we had to get a result of this number. This is simply the accumulation of all data. That's extremely different than setting up an experiment. It's a different animal. The difference, and it's an important difference, because when you set up an experiment and you know you want it to win, you want it to be a successful experiment at a certain level, that's no longer accumulating old stuff. It's now a prospective study, and it requires much more data. It's just the way that the statistics fall out. It also answers different questions. It's a different question that's being asked. Yes?
So notions of precognition, is sort of what you're talking about, violate free will. And free will seems to be very intrinsic to human consciousness. So my question to you is, has it ever occurred to you that even if in fact what you're saying these experiments are evidence of is true, we can't really understand it, at least not in our sort of consciousness that we normally experience, where we experience free will? How do you resolve this conflict in what you're trying to uncover?
Well, assuming that precognition is true, it doesn't necessarily mean that there is no free will, because precognition may be of potential futures. You know, maybe if the multiple worlds hypothesis is correct, that at any given moment in time, you have many possible directions you can go, in which case the precognition is returning information about probable future states.
So this is becoming a very complex theory then, right? So, okay,
Sure.
Granted, if you want to assume all these hyperdimensions and parallel universes and so on, now this theory's getting even crazier, I'll say, right? That's a concern, right? And you can even investigate those sorts of things in other orthogonal dimensions, right? You can try and look for these extra dimensions, and physicists do this, right? There's
Sure.
physics theories that call for hyperdimensions that we don't seem to be able to perceive with what we know.
Right.
I mean, does that concern you? I mean, you're showing us, like, you know, ECGs and measurements of potential and skin conductivity and so forth, and yet, you know, you're also acknowledging that you're invoking some very unsubstantiated notions of science and the universe.
Well, I don't think it's unsubstantiated at all. In fact, of the various phenomena, probably the easiest one to accept is precognition, as strange as that sounds. And the reason is that the fundamental laws of classical mechanics, quantum mechanics, they're completely time-symmetric. There's no reason. And I mean, oftentimes people will say, well, this stuff can't be true because it violates the laws of science. To which I respond, tell me exactly what's being violated. Because the answer is nothing is being violated.
Is inconsistent with the lack of free will in science. So you're exactly right. All the equations of physics are symmetric in time.
Sure.
But you're actually claiming that free will might exist, and then you're invoking more complex ways to get around it.
The curious thing here is that at least within the neurosciences, most neuroscientists will say that there is no free will, that is an illusion. So are they right? Well, I think I have free will, but maybe they are right. So I don't know how to answer this question. This is where it's a difficult theoretical problem. Again, as an empiricist, I simply say, well, look, is the experiment done correctly or not? The result is what it is. We need to be smarter in order to figure out how to fit it into our understanding of the world, rather than a priori saying, well, it doesn't fit any existing theory, therefore I won't pay attention to it. Yes?
I have two related questions. First, what kind of random number generators have you used? And second, if you heard anything about Global Consciousness Project at Princeton?
Yeah. So the random number generators that I typically use are called Orion. It's a circuit made in the Netherlands. It's a truly random generator based on noise out of Zener diodes. It's passed the die-hard suite and so on. It's been used for many years. I've also used a random generator coming out of Giessen's group at the University of Geneva, which is based on when a photon hits a half-silvered mirror, it will go one way or the other, and it can be measured which path it took. So it's based on a quantum optics effect. I use that one sometimes too. In terms of the Global Consciousness Project, that's a 2-hour lecture as well. So I've been involved in that since the beginning. I'm one of the analysts on the project. I probably shouldn't get into it because it's just too complex. It takes too long to describe. But for those of you who maybe wonder what we're talking about something that looks like a global form of mind-matter interaction. That's what it looks like. Yes? So the question basically is, since we're using a random number generator in presentiment studies, could somebody outguess the sequence somehow and guess that maybe the next one's emotional and third one is calm and so on? So one way to address this issue is to look at the actual sequence that comes up and look for autocorrelations in it that might say, well, just accidentally the random generator every third time gave an emotional picture. So we can check that, and it turns out that the random generators are real good. They don't have significant autocorrelations in them. Could it happen on an individual basis that maybe a small sequence could look non-random? Well, of course. Any finite sequence can look non-random. And we're always dealing with finite sequences. Nevertheless, the generators that we use are all tested beforehand for true randomness, as good as we can get. And the sequences used in the actual experiment are tested as well. So in these experiments, we don't find evidence that people are somehow outguessing the random sequence.
There has to go through a certain number of tests before you see this correlation? Do they build up this?
In most cases, we have one person doing one test, typically about 20 to 30 trials. So if there's a possibility, if you have a really crappy random number generator, you have 20 trials to figure it out. And there's no evidence, even within single runs, that people are figuring out what's about to happen. So the other thing is that in early experiments, we used dichotomous samples. We used just emotional and just calm. And I stopped doing that after a while because even though the random sequences were good, it still encouraged people to do a statistical counting in their head. Whereas what I've been doing for the last 8 years or so is picking pictures at random from the entire pool. So it's a huge range of emotionality. And then it becomes virtually impossible to know what the next picture is going to be like, because maybe it's a little bit calmer than the one you just saw, or a lot more emotional. It could be all over the map. And then at the end, I do an analytical cut on the data, where I look at only the results of the data for the most calm and the most emotional, cut across people. And that's where you see this big effect. So in any given run of maybe 20 or 30 trials, maybe I only end up using 2 of them out of the sequence that person saw. But nevertheless, when you do that kind of partitioning on the data, you end up with these results. I think we're done. Thank you all for coming.